After the Big Bang, the universe was like a hot soup of particles. And when the universe started cooling, the protons and neutrons began combining into ionized atoms of hydrogen and eventually some helium. These ionized atoms of hydrogen and helium attracted electrons, turning them into neutral atoms, which allowed light to travel freely for the first time. Since this light was no longer scattering off free electrons, so the universe was no longer opaque. However, it would still be some time before the first sources of light would start to form, ending the cosmic dark ages. So exactly what the universe's first light looked like and exactly when these first stars formed is not known. These are some of the questions Webb was designed to help us to answer. Welcome to Space World. In today's video, we are going to talk about a new discovery before the Big Bang made by James Webb Telescope that will change everything. So, if you want to know more about it, then stay with us until the end of the video. Everything about the James Webb Space Telescope, from its conception to its launch, has been nerve-wracking for scientists. After the successful launch on Christmas from Air and Space's ELA-3 launch complex at Europe's spaceport located near Kourou, French Guiana, many thought that the most difficult part had been done. But that was just the beginning. First light is an important milestone for any telescope, as it is the point where starlight is detected by the observatory and its various instruments. Through this, the observers can enable a months-long alignment of the telescope. Webb's first light came from a star known as HD 84406. It is a Sun-like star and is located 241 light-years from Earth, and part of the constellation Ursa Major, the Great Bear. Now, if you think that Webb has started taking pictures and began a new era of space observations, then that's not the case. These images are not going to be used for research purposes. Rather, they are going to help Webb's mission control team to align the 18 golden segments of the telescope's 21-foot-wide main mirror. So, these images are not the way we expect the telescope to show us, but it's exactly what NASA had expected, and over time, it will be able to adjust to segments to bring the image into focus. John Mather, a Nobel laureate and astrophysicist who also works at NASA's Goddard Space Flight Center in Greenbelt, Maryland, said, "First, we have to find the images that all of those 18 different hexagons are making, then figure out which one is which, and then start sending commands to the little motors that move the viewers around to get them in the right place." The Webb is the vaunted, bigger, and more powerful successor to the Hubble Space Telescope, and astronomers expect that it will pierce a dark curtain of ignorance and supposition about the early days of the universe and allow them to snoop on nearby exoplanets. However, perhaps the most important question about the universe for much of the 20th century was whether it had a beginning, or if it has always been this way. The first snapshot of what the early universe looked like 400,000 years after the Big Bang was taken in the 1990s using NASA's Cosmic Background Explorer satellite. The scientists who led the work were awarded a Nobel Prize in Physics in 2006. According to Dr. Mather, JWST's senior project scientist, "I am hoping that it will tell us about the beginning of everything. If all we do is confirm the story we've already got, that would be interesting. But I think it's also possible that there's something that we haven't guessed out there yet to be discovered." Webb's predecessor, the Hubble telescope, has meant so much during its 30-year run, as it has sent us unforgettable, jaw-droppingly beautiful images like those of the Lagoon Nebula and the Pillars of Creation. It's also taught us about the age of the universe, about what happens when stars explode, about black holes, helping us build boundaries with which the Webb will push forward. Most powerfully, its observations have led scientists to believe the universe is expanding at an accelerating rate, propelled by something so mysterious that scientists simply call it dark energy. On the other hand, the Webb telescope is named after James Webb, the man who led NASA in the decade leading up to the moon landing. The technological achievement of the NASA's new telescope is going to be uncontroversial because it is set to take the success of the Hubble one step ahead. Amber Strawn, an astrophysicist at NASA who works on the Webb, has stated that what we're going to get is a telescope that's about 100 times more powerful than Hubble. But the question is, how will the Webb outperform Hubble? The Webb has two major advantages over Hubble, and the first one is its size. Hubble was about the size of a school bus, but the Webb, on the other hand, is more like the size of a tennis court. Strawn has also praised its size and said, "This thing is enormous. Webb is by far the biggest telescope NASA's ever attempted to send into space." However, it's not the size which is going to make the Webb extraordinary. When it comes to reflecting telescopes, the key component is the size of its curved mirror. The more light you can collect in this bucket, the fainter and farther away things you can see in the universe. Hubble's mirror was an impressive 7.8 feet in diameter, and comparatively, Webb's beautiful gold-hued mirrors combine for a diameter of 21.3 feet, which overall amounts to more than 6 times the light-collecting area. To put it in simple words, let's consider one of Hubble's most famous images, the Deep Field. In 1995, scientists set the Hubble to stare off into a teeny-tiny patch of sky and capture as much light as it could from that one spot. As a result of this, Hubble uncovered thousands of galaxies in this teensy patch of sky, helping us refine the number of galaxies thought to exist in the universe. It was not just an image, but it also helped to reveal Hubble's power to act as a time machine, because in astronomy, the farther the things are, the older they are. Therefore, Austin Casey, an assistant professor of astronomy at the University of Texas at Austin, is very confident about the performance of the Webb in this regard. As she stated, what Webb will do is take that field and go even further. So the tiny specks of light in the background of the Hubble Deep Field will brighten and become more detailed. We'll be able to see spiral arms, and we'll be able to see structure. And then we'll get more specks of light and even further in the past. We're seeing further back in time with Webb. So, Casey and other astronomers are very hopeful that the Webb will help them understand the end of the Dark Ages and figure out what caused this fog to lift, ushering in cosmic dawn. The second advantage the Webb has over Hubble is the amount of light it collects. The Hubble telescope can collect visible light, ultraviolet light, and a little bit of infrared, but the Webb is primarily an infrared telescope, so it sees light that's in a longer wavelength than what our eyes can see. Because space is constantly expanding, the farthest things away from us in the universe are moving away from us. So, Webb will be the first telescope of its kind in terms of size, sensitivity, and wavelength range altogether. With its infrared capabilities, a good chance exists scientists will get to see something they've never seen before. And this is it for today, guys. What are your thoughts on today's video? Do you believe that we have actually a second home, humans to survive and thrive? Share your views with us in the comments below. And don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.